Okay, so we're going to practice balancing nuclear chemical equations. We're going to do these three, and then you're going to have the two that we're not going to do to work on by yourself. So the way this is going to work is we are going to treat everything like an algebra formula. Okay. Now, when I look at the question mark right here, I usually will write this in there simply because this will help me make sure I solve for the right things when I set up my formula. So I put a question mark here because that's the way it most of the time looks, is when potassium captures an electron, which is this is potassium, this is an electron, what's it going to form? And so what we're going to do is we're going to put a plus sign. We're going to make the arrow an equal sign because the left must equal the right. That's conservation of mass and charge. And then we're going to solve for the formulas. So the top formula is going to be 42 plus 0 equals x. Now, what you may see here, zoom in, is that x is equal to 42 because 42 plus 0 is still 42. The bottom set of numbers is going to become 19 plus minus 1 equals y. I'm going to highlight these. And so what this will tell us is that when I take 19 and I subtract 1, because that's plus a minus number, y is going to be equal to 18. And then what I'm going to do is I'm going to use this number because this is the atomic number, and the atomic number will always be the same no matter what isotope we're looking at. The atomic number, the number of protons, will never change. We're going to find a periodic table, and we're going to see that over here element number 18 is argon. So we're going to go back and we're going to write 42 and 18 and argon. So when potassium gains an electron or a beta particle, it forms argon. Okay, so let's practice another one. I'm going to highlight the numbers. 235 plus question mark equals 231, and 92 plus question mark equals 90. So I'm going to have 235 plus x is equal to 231. I have this backwards. It should be this. Okay. So this is going to be 235 equals x plus 231. The bottom one is going to be 92 equals y plus 90. So now what I'm going to do is I'm going to solve for x and y. And in this case, I'm going to get that in order for x, or in order for the left to equal the right on the yellow equation, x must be equal to 4 because 231 plus 4 equals 235, and y is going to be equal to 2 because 90 plus 2 is 92. So what this is, it's going to be 4, 2. And so you need to know the different particles. So you remember we had the alpha particle, which was also a helium. We have the beta particle, which was also an electron, and then we have the gamma ray. So in this case, the 4 and the 2 match up with an alpha particle, or you could write helium. Both of them are correct. They would be counted correct. And so when uranium decomposes, it's going to release an alpha particle and form thorium. So let's go down and do the last one. Now the reason why we're going to skip and do the last one is because there are 4. So we have 238 plus 4 yields what we don't know plus 1. So we're going to have a pretty long equation over there. And then we're going to take 92 plus 2 equals what we don't know plus 0, and a pretty long equation over here. So I have 238 plus 4 equals x plus 1. And this is going to be 92 plus 2 equals y plus 0. All right, so what this is going to be is I'm going to add the two numbers on the left to get 242 equals x plus 1. So to get it to the other side, you subtract. And this is going to give me x is equal to 241. Down the bottom, it's going to be 94 is equal to y plus 0. And the y is going to become 94. It's going to be equal to 94. And so in this case, I'm going to have 241, 94. Now I need to go back to my periodic table. I'm going to use number 94. And you can see down here that element number 94 at the very bottom pink row is plutonium. Also Pu, like Pu, stinky. And then we're going to fill that in. Now you might be asking yourself what this particle is, and this is a neutron because it has no charge and has a mass of 1. Okay, so that's a neutron that's being lost there. Right? So we practice 3, you're going to do 2, and then you're going to submit this assignment. You probably have done this on a piece of paper, and you're going to take a picture and upload it. If you did this on like a Google Docs, which might be a little bit harder, then you'll just upload your submission